Hello, I've had a question about Unit 2, Lesson 8, 7D. So, we want to determine a vector equation of each of the following planes, and D, a plane containing two parallel lines. The problem with parallel lines on a plane is that we need two direction vectors to define the plane, but if the direction vectors from those two lines are in the same direction, it's no good to us. So we can use one of the direction vectors. Doesn't matter which one. So for the plane, I will pick the first direction vector to be 4, 2, negative 4. I have a point, since it doesn't matter which point I pick, because both lines are going to be on the plane. We can do that, but it's the second direction vector, and here's the key. We know the reference point from the first line, so let's call that the first reference point. We got a reference point from the second one. Let's call it over here. So that means that if we use those two reference points, I can get another or a second direction vector. So my second direction vector is going to be the coordinates negative 4, 5, negative 4. That's from the second line, minus the reference point from the first one, 0, 1, 3. That will result in a vector, 4 and negative 7. So there's the second vector. So there's the key to that one. So your equation of your plane, x, y, z, will equal, so we have 0, 1, 3 as our reference point, plus, now this is where you gotta be careful, communication-wise. Variable t has been used, variable s is used, can't use those. So let's go to m, my first direction vector, 4, 2, negative 4. And then I have my second direction vector, n, negative 4, 4, negative 7. And that's how you end up, if you have two parallel lines, that's how you get that second direction vector to work with. So if you have any questions with that, let me know.